Hey Pre-calc, here's another lesson for 5-2, if you need to watch it. So in this one we're verifying trig identity. So here are the proofs, yay, that I've been saying that I love. So in this section we are solving conditional equations and verifying identities, which you can read there for yourself. And remember, a conditional equation is only true for some values in the domain. And for example, the sine of x equals 0, that's true for only when x equals any n pi, where n is an integer. On the other hand, the identity is an equation that is true for all real numbers in the domain. An example of that, as you can read there, is sine squared of x equals 1 minus cosine squared of x. So we're going to jump into verifying identities right away. And so some important things to remember when you're doing this. You never work with both sides of the identity of the equal sign. You pick one side, you work it down, and you get to the other side. So I should never see both sides. You're doing things to both sides of the equation here. Other things, some of you are going to be frustrated with this. You might start to do something and you hit a dead end. Don't do this in pen. It's going to be frustrating for you. It can be very rewarding, but also frustrating. Other tips, look to try to factor, add in fractions, try squaring things, or a single term denominator. These are just hints that you'll see me do along the way. Try to use those fundamental identities that we know. Look to where you want to get to and see how could you kind of backtrack to maybe get there. As a last resort, you could always convert all terms to sine and cosine and see if that gets you anywhere. Always try something, because even if you get to a dead end, you might realize something along the way. So these take a lot of trial and error for people. Obviously, I have these done out. I've done them out already, so you don't see me being frustrated about them. But so here's the first one that we're going to do. And looking at this, so you have to verify that sine squared x minus 1 divided by sine squared of x equals negative cotangent squared of x. So I'm going to choose to start on the left because I think I can do more to that instead of the negative cotangent squared. And that's not to say you couldn't start with the right hand side. But so here we go. I'm going to start on the left. All right, and so what I'm going to do is I'm going to try to break up that the numerator. So I'm going to have sine squared of x. Again, you need to write x every time, or whatever it is you're taking the sine or cotangent or whatever it is of. My denominator is sine squared of x. Again, all I'm doing right here is breaking up that numerator. Okay? Remember, that still equals the negative cotangent squared of x. I didn't do anything to that. I just changed the left-hand side. Okay, so now sine squared of x over sine squared of x, that's 1. Okay? I also know that 1 divided by sine squared of x, that is cosecant squared of x. Remember, the right-hand side has not changed. Okay. So now again, think what you want to get to. You have to introduce somehow a cotangent squared in here. So look back to your identities. We know that cosecant squared of x is 1 plus the cotangent squared of x. Okay, again, that was one of the tricks. Use your identities. Excuse me. So now, if you distribute in that negative, you're going to see that our 1's cancel. So again, if I wanted to show out all the steps, which showing more is better than less in this case, because we do not give credit when things just appear. We need to kind of see you prove your way along. And so there you go. When I was in college, I was taught after you're done with a proof to do a box to say the end. Some teachers do QED. I've always done the box. But there's my first proof.